All right, here we go. So last time we were talking about a couple of things, right? We had the main concepts were a system of linear equations in two variables. Just going to do a quick review. We had system of linear equations in two variables. And that was basically linear equations meant that we were going to draw lines, right? And we were trying to figure out where they intersect. I mean, that was the visual representation of what was happening. We had two lines wherever they are and trying to find the point of intersection. This would be our solution, right? Our solution to that. Now, oh yeah, and it's a point. It has some x and y coordinate to it. We didn't talk about this last time, but now I'll ask you, is it possible to have a system of linear equations and not have a solution? Yes. How? Think of it visually. Two parallel lines that don't intersect each other, right? So if I were to have a situation like this, where I have, let's say, this line, and then I have another line like this, there should be no solution. We're not going to discuss that, okay, because we're going to get into more interesting things. But it is possible to get no solution. And it's actually also possible to get an infinite number of solutions. And that would be if you were given two equations and they turned out to be the same exact line. So then what you would have is, instead of that blue line and green line being separated, you would have the same line right on top of the other one. In that case, every point that corresponds to each line is a solution. So with linear equations in two variables, you have three possibilities. One point as a solution, which is, again, all we're going to deal with. No solutions, or infinite number of solutions. With me? That's the first thing. Now, after that, we discussed the next idea, which was a linear inequality. In two variables. And for this, what we had was, same thing, a line, right? And then we'd wind up shading either everything below, or we would shade everything above, right? We'd have to do test points and stuff like that. And we also had to consider the possibility of that line being dotted instead of solid, right? Then, at the very end of class, and we really didn't get an opportunity to do it properly, I think I only did one example. I was trying to get us to do a system of linear inequalities. That's where we're going to pick up today. In two variables. So the idea here is this. I give you a system of linear inequalities. That means I give you multiple linear inequalities. And you wind up drawing one of them. So maybe one of them turns out to be a dotted line. And then maybe it's everything shaded above it, right? You figure that one out. Then you go figure out the other one, which maybe it turns out to be a solid line like this. And maybe it's everything shaded below it, like that. And then our final solution is what? Yeah, it's where they overlap. It's their intersection. So our final answer would be this picture. Oh, that didn't come out too good. There we go. Everything in here, like this. So what I could do now, because I have fancy computers, I could take the green out. I could take the blue out. I could take that little yellow part out. And that would be our answer. And if I wanted to be really technical about it, I could even, oh, remember I tried that one time and it messed it up. I'm not going to do that. I could do this. Right? Take everything out that doesn't matter. It would be that shaded region. Now remember, that region goes up forever. It comes down forever. It just stays above this dotted line and below that solid line, right? You'll still look thrilled. You've carried all your thrill over from last class, I can tell. Does everyone understand visually what's happening? So we're going to do another one of these today to start. And then where we're going is this. Where we're headed is that I will give us a system of linear inequalities, but it's going to be more than just 2 lines. It might be 3, and it might even be 4. And so what we'll get is something like this. Let's just say as an example, we get maybe one line that does this, and maybe it's everything shaded below it. And then we get another line that is maybe something like this, and it's everything shaded below that. And then maybe another line that does, let's say, where can I do it? Like this. And everything shaded above it. It's starting to look like I'm just a kindergartner here, right? Just scribbling all over the page. But do you see where our solution would be if it had to be everything everything below the green line, everything below the red line, everything above the black line? Do y'all see that triangle in here? You have 3 points where they hit, which means, shit, we're going to have to find those 3 points. We're going to actually have to find them. And remember, that's going to be that substitution method that we looked at last time. So we're going to have to find 3 intersection points and then come in here and actually shade in the final solution like this. Make sense? Anybody here doing business, taking business classes after this? You'll do this. These are called, this is what you use to find optimization. So what you do is you find what's called the feasible region. This is the feasible region. And then what you have is another function that's defined on top of these. And it's beyond what we're going to do right now. But 1324, you'll do this. Okay? So you'll be happier once you get there and you'll see, oh, I've done this. At least part of the problem you've done. All right. I do have one correction. I did something last class that was incorrect in my wording of things, so I just want to correct it real quick. Where am I? Week 13. Do you remember this example where I was saying, hey, you know, where would you ever want to know that intersection point? And I was talking about profit and cost. Technically, I should have said revenue and cost. Okay, cost is how much, like if I have a company, cost is how much it costs me to pay the bills, pay my employees. Revenue is how much money I collect. Profit is the difference between the two. So I should have put revenue up there, not cost. Revenue instead of profit. So that's just a correction from last time. I want to be clear on that, especially for those going on Take Business. Profit equals revenue minus cost. So if I would have left that as profit, it wouldn't have made sense. All right, let's get to an example for today. I would like for us to solve this. Well, you tell me what this is. Let's go. Try and help lead us into where we're headed later. All right, let's do x plus y less than or equal to 9. And where's that one? Can't read this. X plus 3y less than or equal to 21. I actually am stealing these problems right now from the book, the business math book. Okay, so I'd like to solve this. Now, what is this? I mean, let's just at least get the language correct here. What are we looking at? Okay, we have two variables, but what are each of those individually? Linear inequalities, right? Not linear equations, linear inequalities. So we have two linear inequalities and two variables. Since we have two of them, it's a system. So this is called a system of linear inequalities, and then, in two variables. You don't have to really care too much about that, but it makes a difference. Two variables changes it. Three variables, remember I said we're going to be in three-dimensional space, and everything changes. Okay, so to do this, we have a couple of ways to approach it. I'm going to give you the way to approach it. I think that it'll help you later, all right, when we get three linear inequalities or four of them. If you approach it this way, I think it'll make everything run smooth later. So here's the first thing we're going to do. First thing we're going to do is we're going to turn all inequalities into equations. And do a rough sketch of each. Well, I'll say of all of them. So I want to put them all on the same picture. I don't want to do one drawing and then a separate drawing and then a separate. I want to do them all in the same picture. So let's take our first linear inequality up here. Let's take that one right here. We'll call this, how about L1? Is that all right? The other one will be L2. Later on, we'll have L3. We'll have L4. So L1, if I switch it to an equation, is the line x plus y equals 9. If I try and graph that, I'll solve for y. So I'll move the x to the other side and get y equals negative x plus 9. And why do I solve for y? So how do I graph it? That's right, because what I'm trying to do is get it to look like y equals mx plus b. And if we know y equals mx plus b, we start by plotting b, right? And then we use the slope to move to another point. Once we have 2 points, we draw a straight line. Okay? Now, because I'm going to have to do the same thing for L2, I'm going to go ahead and do that now before I graph it. You didn't realize you were going to be having this much fun this morning, did you? Okay. Drift about it. All right, so here's my next one. I change my inequality to an equation. I move my x to the other side, but there's one additional step I need to take. What is it? Divide everything by 3. So I'm going to have y equals, the way I'm going to write this is negative 1/3 x plus 7. Do you all agree? I'm even putting Izzy to sleep. Look at this. Gone. Just start talking math, and it's just like a natural sedative. All right. So those are our two equations, right? So let's graph them. Man, I made a mess. Let me try and get them, well, I'll start it on a new page. And I would recommend you give yourself, don't be shy about using an entire page for your picture, because you're going to be having to, find intersection points and shading and stuff. Don't try and cram yourself into a little 1-inch by 1-inch square in the corner of your page. All right, so here we go. Here's my axes. There we go. And I have y-intercepts of what and what? 9 and 7, weren't they? So let's start with L1. L1 had a y-intercept of, it was y equals negative x plus 9. The other one was y equals negative 1/3 x plus 7. My 3 looks like it's falling over there. That's my L1. That's my L2. All right, so y-intercepts of 9. So let me go ahead and go up 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you want to get graph paper to do this, that's fine. It might make your life a lot easier. What I'm going to do is, and this is a promise I'm going to make to you, all of your y-intercepts are going to be integers. All right, on all the problems I give you, like on a test or anything like that, they'll all be integers. And where your lines intersect are going to be integers too. So you're not going to have weird things like, okay, I have a y-intercept of 3.7, and then when you find the intersection point, some weird decimals. All right, that way it'll just keep your math cleaner. It's more, for me, it's more about the concept here. So here's 9. So I'm going to draw my L1, let's say in blue. I'm going to have my y-intercept. Now, to get to another point, what do? What's the slope of L1? The slope is -1, right? That negative in front of x means -1. So that means rise over run, down 1, right 1. Okay, so from that point, go down 1 and to the right 1. And I could draw a dot there, or I could go down 1, right 1 again and draw a dot. It doesn't matter. I'm just going to go down 1 to the right 1 and draw my dot. And draw my line, right? Now, let's be a little careful here, because in the past we've just drawn it, we haven't cared too much. Would you agree that if you draw it like this, if you come in here and draw this right now, you're going to have kind of a tough time figuring out like where it hits down there? It's going to be an okay picture, but it's not perfect. We want to get as good as we can here. So what I'm going to do is I'm going to do one additional thing. I'm going to try and figure out where it hits the x-axis. So how would I find an x-intercept? Do you remember how to find an x-intercept of anything? Set y to 0 and solve. So go to L1 and plug in 0 for y. That means you have to move the x back over. What would you get if you plug in 0 for y on L1? X is 9. So your y and x-intercepts are actually the same exact thing. Do you want me to show that step, or is it okay if we do it mentally? I don't care. Just show it? Okay. So what I'm going to do is I'm going to take L1 here. To find the x-intercept, I'm going to set y to 0. So 0 equals negative x plus 9. Add x to both sides. X is 9. With me? So 1, 2, 3, 4, 5, 6, 7, 8. Here's 9 on my x-axis. And I know I have a blue dot there. And now I'm going to connect those points together. And that'll be a pretty good picture. Oh, you know what? Yeah, that's true. Oh, I thought you were referring to you. Hold on, I'm trying to remember how to change this now. What the heck? I'm trying to change this line to blue, but I've forgotten. There we go. There it is. There we go. Okay. So there's my L1, right? And now L2. So L2 I'll do in black. And I have a y-intercept of 7. How do I get to another point? Down 1, to the right, 1, 2, 3. I don't know. Maybe it hits there. I'm not sure. It's hard to tell, isn't it? It is going to hit eventually, right? Can you find the the x-intercept for L2? The x-intercept, yep, you set y to 0. You set y to 0. Negative 1/3 x plus 7. You move your negative 1/3 x to the other side, and you multiply both sides by 3. Unfortunately, that's off my graph, isn't it? So I'm just going to draw my line. And if at the end of it all I have to redraw the whole thing, I'll redraw the whole thing. But for now, I'm going to try and get away with just this. That's not what I wanted. All right. They definitely hit each other, don't they? Somewhere? All right. Now, I should have pointed this out. I didn't. I drew them both solid. Why did I draw them both solid? Because the inequality, remember, right? The inequalities had equal signs on them. So let's go back over here real quick. See this, the step I had given you? Turn all inequalities into equations and do a rough sketch of all. Let's add a little note to that. Solid, right? If the inequality has the equal sign. Dotted if it's just the strict inequality. So let me put it this way. Solid if you have this or this. Dotted if you have this or this. That makes sense? Just add that in there as a little side note. All right. So we've done that step, haven't we? Now what we need to do is figure out the shading. So to do that, do y'all remember how we figure out the shading? You test a point, right? You test any point that doesn't lie on the lines. Now, I always said 0, 0, as long as your lines don't go through 0, 0. Do our lines go through 0, 0? No. So let's go back and I'll write that as our next step. Our next step in this process will be to shade above or below each line using any test point so long as it doesn't lie on the line. 0, 0 is usually a good choice, right? As long as it doesn't lie on the line. And we like 0, 0 because it's easy to plug 0 in for x and 0 in for y, isn't it? Now, we have to do that test point for each of our lines, right, or inequalities, into the original inequality, correct? All right? Yeah. So I'll add that if that helps. Plug into original inequality. No, because the test point is just to see for each inequality by itself, is it below or above? Okay? As opposed to finding the intersection, which is a point which must satisfy both at the same time. All right, y'all okay? All right, now let's do that step. Where am I? So I'm going to write down the system right over here that we had before. With L1, it came from y. It was x plus y less than or equal to 9, right? The other one came from 1/3 x plus y was less than or equal to 21, right? No, x plus 3y. Sorry. Thank you. All right, so you ready to get a test point? Okay, I'm going to right now, I'm going to test the point 0, 0 into the first inequality, x plus y less than or equal to 9. That gives me 0 plus 0 is less than or equal to 9, which is 0 is less than or equal to 9, right? And that's true. Now, where's our test point? 0, 0? It's the origin, right? I'm highlighting it there in yellow. What we're saying is that that point satisfies the inequality. So that point is on the side that should be shaded. Of which line, though? The blue line, because that's the one I was checking. So because later on we're going to have lots of shading, let's be kind of not too generous with our shading here. I'm going to go as lightly as possible here. Just going to shade below the blue line like this. Just below the blue, though. Is that all right? Remember, that extends forever. Yes. You want to use your crowns? Yeah, you can. You can use colored pencils. If you're comfortable with it. If you see it all and see what they have in common, you can just give me that final shaded part. That's fine. You don't have to show me this, but, you know, yeah, swim at your own risk kind of thing. Okay, next test. I'm going to do the same test, right? I'm going to test 0, 0 into the second inequality, which was x plus 3y less than or equal to 21. If you do that, you get 0 is less than or equal to 21 again, and that works. So I'm going to shade everything below the black line. Now, just so that we remember, what happens if it didn't work? Do you have to go pick another test point? No, you just shade the opposite side. So it's a yes or no. If it's yes, you shade that side. If it's no, you shade the other side. Okay? So now I'm going to shade everything below the black. Right? And now I'm ready to try and figure out what overlaps. So check this out. I'm going to do this point here. I'm going to make it really big. That point obviously is not a solution, right? That point doesn't live in the solution. This point satisfies the blue inequality, but not the black one. This one satisfies the black, but not the blue. But everything here and below, right? Everything in there satisfies both. And that's what we're looking for. But we're not done. Okay? Let me take those dots out. The last thing that you need to do is to figure out this point. Where do they hit each other? Now, again, this goes back to the business students. You're going to want to know this region. You're going to want to know all the corners, all the points where they intersect. You're going to want to know these because there's a theorem that says later on that all maximums for functions occur somewhere on the boundary, and they occur at the corner points. So you have to be able to find the corner points. Anyway, all right, that's beyond the scope of this class. But we, in here, see, this is a beautiful problem, isn't it? Because you actually are now going to have to find the point of intersection of two lines, which is a system of linear equations. So this one problem kills off like a couple of things all at one time. You see that? So here's our final, let me go back to our steps, because you like steps, right? So we shaded, right? We shaded above or below each line using any test point, so long as it does not lie on line. 0, 0 is usually a good choice. Plug in the original inequality. What do we do after that? We shaded what's in common to all of them, right? How do you want me to say that? What would make most sense to you? I mean, I know what makes sense to me, but okay. So shade. I'll say your answer is what they have in common. So shade where they overlap. I should also point out where they all overlap. All of them, okay? All of them. And then after you do that, which we've already done, right? We will find all intersection points. And label them on the graph. Make sure you bring washable markers if you're going to use markers on test. I don't want you making a mess here. So. Washable. Pencils, yeah. So graph paper and pencils, for those of you who are like real artsy and like to draw things and stuff, this might actually be kind of fun. I don't know if fun's the word, but an opportunity for you to use some of your school supplies. We're not done, Izzy, sorry. Just getting started. All right, let's get that intersection point. Now, I say we need to get it, but how do you get it? How do we get that intersection point? You're going to have to switch that system of linear inequalities into a system of linear equations and then use substitution. So that's what I'm doing now. So I'm going to start a new page for this. So now, to find intersection, that's the point of L1 and L2, we solve the following system of equations. It was x plus y. We switch it from less than or equal to equal. X plus 3y equals 21. Equations. All right? They're equations now, not inequalities. So I'm going to use substitution. And there was a whole set of steps for substitution. Remember those? Maybe not, but you have them written down perhaps? This is where you got to choose one of the equations and pick either one of the variables and solve for that, right? So I'm going to pick equation, let's say equation 1, and I'm going to solve for, what do you want to solve for? For y. Okay. All right. So I take equation 1 and I move the x over. And we had done that earlier, so it's kind of, you know, repeating ourselves here. All right, once you do that, what do? Plug it into the other equation for y. So I'm going to plug into x plus 3y equals 21. I'm replacing the y with negative x plus 9. So it becomes x plus 3, and then in parentheses, y is negative x plus 9 equals 21. Distribute your 3 and collect like terms. You should get negative 2x plus 27 equals 21. Do you all agree with that? It was negative 3x, but then I put it together with the x in front. Now solve this linear equation. That's the third step. Solve. So move your 27 over, which gives you a negative 6. Divide by negative 2, and you should get x is 3. Yeah, and the fourth step, and I'll do it over here, try and keep it all on one page. I'm going to plug into the answer I got from 1, right? So I'm going to plug this answer into y equals negative x plus 9. And I'm going to plug it in for x, right? That x right there is going to be replaced with 3. So y equals negative 3 plus 9, which is, I don't know why I know why I put 6, but 6. So what is the point of intersection? Yep, intersection is the point 3, 6. And just make sure you get that order correct, right? It's not 6, 3, it's 3, 6. 3 was the x, 6 was the y. That all make sense? So let's go back to our graph now, and we'll plot that point on there, and we'll be done. Can I change pages or keep it up for a second? Switch. Okay, so that point back here that I was questioning, I'm now going to label this point as the point 3, 6. Does that look correct? To the right 3 and then up 6? It looks about right. So I'm happy with that. Let's see, it's 10, 10. Yeah, that took a while, didn't it? All right, 20. All right, let's try this now. We're going to turn the screws. All right, you see we're done with that? I mean, what am I looking for? What's the final answer? The picture, the whole graph is your answer, okay? So that's what we're looking for. And then each of the pieces in between. I don't even know if it'll be that much. I really only envision one of these. One of what I'm about to do. These. That's what I'm envisioning. Let's see how this goes, all right? Let's solve this right here. Actually, make your brace pretty big here. Oh wait, hold on, that's what I'm going to give you for homework. 3x plus y less than or equal to 21. X plus y less than or equal to 9. X plus 3y less than or equal to 21. X greater than or equal to 0. Y greater than or equal to 0. It looks pretty bad, right? You know how they say sometimes, things aren't as bad as they look? This is not one of those cases. This is as bad as it looks. No, I'm kidding. No, look, this is not as bad as it looks. All right. Copy it down. Let's talk about it first. What we have here are 5 inequalities, right? 5 inequalities. The first 3 are linear inequalities in 2 variables, aren't they? The first 3 are just lines, but we're going to shade one side or the other. They're all solid lines too, right? All right. The last 2, x is greater than or equal to 0 and y is greater than or equal to 0. Those are actually lines also. They just don't look like lines. Do you remember, maybe not, that if I say x equals 2 and I ask you to graph that as a line, it would be a vertical line? And if I put y equals 4, it's a horizontal line? Okay, so x equals 2 is a vertical line, y equals 4 is a horizontal line. Well, we basically have the same thing here, except the last 2, remember we switch everything to an equation first? The last one is x equals 0, which is a vertical line through 0. Y equals 0 is a horizontal line through 0. So basically that's the x and y axes, which is going to include the origin. But then we're going to shade a certain side of it. But you won't need to. Just think about this for a second. Think about your plane here. If I say, hey, where is x bigger than or equal to 0? Are you on the right side or on the left side of the y-axis? Right side, right? X greater than or equal to 0 just means the right side. What does y greater than or equal to 0 mean? Up. So doesn't x being greater than 0 and y being greater than 0 at the same time mean this? That's all it does. It locks you in the first, what we call quadrant. So those last 2 inequalities lock you over here and stop you from having to shade everything out over here. So it's not, those 2 last ones are not as bad as you would think. And again, this is connected to business. When you're selling things or you have people that you're paying, X might be the number of cell phones you sell, right? Well, X isn't going to be negative. So you're only going to look to the right. And then Y might be the number of employees you have. So you're not going to have a negative number of employees. So in most business problems, in real world, I always have a hard time with that. Real world problems, your 2 variables are usually positive. They're never usually negative numbers. Okay. Unless you're selling negative, that means you have an employee stealing. All right. What's the first step I'm going to do here? Okay, turn them all to equations. All right, so I'm going to turn 3x, and I'll call it L1. L1 is 3x plus y equals 21. Next one was x plus y equals 9. Next one was x plus 3y equals 21. Do those second 2 look familiar? We did those just a second ago, didn't we? The last 2 are x is 0 and y is 0. Now we solve each of them for y so we can graph them, right? I'll do that next to them so I can graph them easily. Y equals negative 3x plus 21. Y equals negative x plus 9. Y equals negative 1/3 x plus 7. The last 2 don't change. Now, I went through the second and third lines quickly because we've done them, right? And I forgot to label them. We'll call L2, L3, L4, L5. That way, you'll see later we're going to have to reference this. We have to come back and talk about, well, which line are you talking about? The first, second, third, fourth, or fifth? All right, you ready to graph all these? The only one that's new, right, is this one right here. This y equals negative 3x plus 21. Now, we learned from our last graph, we didn't draw it big enough. Remember, we couldn't go out, like we were supposed to go out 21 and we kind of ran out of room. With that in mind now, and knowing that my y-intercept on that first line is 21, I'm going to draw my graph pretty big. Like it's going to go out pretty far on my x and y. But I'm also going to keep in mind what we were just talking about, that we're going to be stuck in the first quadrant. Our x is bigger than 0 and y. So I'm not going to draw a bunch of crap on the other side because I don't need it. So here's what my picture is going to look like. More like this. Is that okay? So I'm just focusing a lot of my attention just on that top right corner of the plane. That sounded like you were upset. Let me shut that. All right, so I'm going to go, let's say 25 in each direction maybe. And you can mark each one of them if you want, or you can go count by fives, whatever you want. I'm going to mark each one. I lied. I'm only going 22. And 21. So there's 21 right there. Here's 21 over here. That's a pretty good picture, I might say. Now, I could have really cheated and just done this, but I'm not going to do it because you're not able to do that easily. But that's where graph paper might make this a little easier, and a ruler and stuff. Sounds like fun. Sounds like an art project. All right, so let's do the lines we already knew, right? Which lines did we know? L2? What was L2 for in our problem now? L2 is that one that had a y-intercept of 9, and then it went down one, right? Down one, right one. So it had an x and y-intercept of 9, didn't it? Hello? Line 2? Okay, so I'm going to draw line 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9. And I'll draw this in blue. 3, 4, 5, 6, 7, 8, 9. There it is. And it's going to be a solid line through those two. Yeah. I'm going to label it, everyone, okay? I'm going to label it right over here. I'm going to call it L2 so that we all know which one I'm talking about, right? That's L2. And then do L1, or no, L3 now because we know what L3 looks like. L3 had a y-intercept of 7, right? And an x-intercept of 21, right? Does anyone have any questions? Are you ready, like thinking turkey and stuff right now, or what? Go ahead and see if you can figure out how to draw L1 while I'm playing here. Don't forget to label this one L3, right? I'm going to do my work for L1 back on this page. The y-intercept is 21. The x-intercept, 0 equals negative 3y, 3x plus 21. Anyone have the x-intercept for L1 yet? 7. Good. So all I'm doing is, we know the y-intercept for L1 because of y equals mx plus b. To get the x-intercept, we set y to 0. We solve it. We get x is 7. So x-intercept is 7, y-intercept of 21. May I proceed? Yes? Okay, so now I'm going to draw this one. I'll do it in green. Y-intercept way up here at 21. X-intercept down here at 7. 1, 2, 3, 4, 5, 6, 7. That's here. And call this L3. Oh, yeah, thank you. See, y'all are paying attention. I sit here and I made a mistake. I wasn't testing you. I made a mistake. Thinking about refilling this drink. All right. So now let's get x is, the next one we have is L4, right? We said L4 was x is greater than 0, isn't it? Now, it's going to be hard to draw x is greater than 0 because, or x is equal to 0 because it's a vertical line. It's the y-axis, isn't it? So I don't know how you want to do this. I'm just going to highlight my x-axis like this. Yes?
So on line 1, where did you get the 7 from?
Well, you can do it that way. I did it this way. I took the line. I found the x-intercept by replacing y with 0, moving the 3x to the left, or negative 3x to the left, so I added 3x both sides, and then dividing by 7. I mean, dividing by 3, which gave me 7. Is that okay? All right. See, because the slope is good, but when you start to have a bunch of lines, it's better to just try and grab those x and y intercepts. But you should be comfortable with both. All right, is that okay for my x equals 0? So that's, I'll call that L4. And then L5 is the y-axis, right? Y equals 0. So again, that's going to be kind of hard to highlight. Did I say y? X-axis. Sorry. That's L5. All right, let's try and do this. Now, I'm going to do this slightly different because we have a bunch of stuff up here, and it could be really a disaster if we try and shade all this, do the first one, then the second one, third one, fourth one, fifth one. So I'm going to do it the way most books will do it when you have multiple lines like this. First, let's figure out, we need to test for L1, right? You can test 0, 0 for L1 because L1 doesn't have 0, 0 on it. So I can pick 0, 0. So everyone test 0, 0 into L1 right now. Well, you got to be careful with inequalities because sometimes they don't act the way you think they act. So testing a point doesn't take a whole lot of time, so just check it real quick. Now I'm testing 0, 0 into L1, which means I'm testing it into 3x plus y less than or equal to 21. And does that work? 0 is less than or equal to 21. That works. So I will shade, now don't do it yet, but I will shade everything, what? Below, which is looks more like to the left, doesn't it? It still has an angle. So it's everything kind of below and to the left. Now, since L2 and L3 we did last problem, those are the same things, aren't they? Below and below. And then when we did x is greater than 0, sorry, Izzy. When we said x is greater than 0, you don't need a test point. It's just to the right, isn't it? Y is greater than 0 means everything up. So you don't need test points for those. Well, watch the way I'm going to do this. Let me do L1 first. We said everything below, right? So I'm going to draw little arrows. Instead of doing all those lines, just little arrows. Doesn't that mean I'm going to do everything to that side of the line? See the way I did that? Then for the black line, blue line is where we are now, L2, it's everything below L2. And then L3, everything below L3. What about L4? Everything to the right. So, and then for L5, everything above. Now, the arrows may confuse you, the arrows may make it easier. Everyone's brain works a little different here. What you're looking for is something that you would have all arrows up. Where's the region that has all the arrows pointing into it? So let me show you things that wouldn't work. This wouldn't work, right, that point? Because none of the arrows even point to that, right? I mean, well, the ones down here do, right? They point to that. And these here point to it, but all the others don't point to it, right? So that's not going to work. How about this one right here? Y'all see the one I put here? This points to it, this points to it, these don't. So that won't work. Same with this one. The blue and the black don't point to it, right? So how about that little triangular region right here in the center, right there, that little region? No, that doesn't work either. The black one points to it, green one points to it, this points to it, this points to it, but the blue points away, doesn't it? The only region, no. I don't know if I'm going to be able to erase that.
What the hell? Just leave it. Choose a different color.
See if I can outwit this thing. Nope, I can't. Oh, well. So now everyone's confused because I can't erase that, right? So your correct answer is everything here, right? Till you get to that corner, comes down like this, comes over, and then comes over and across and goes up. Everything in there, right? So we have a shape. It's not a triangle. It's not a square. It's a, let's see, how many sides are there? 1, 2, 3, 4, 5. It's a five-sided polygon. It's not a pentagon. Pentagons are usually equal sides. How many points of intersection do we have? We have 1, 2, 3, 4, 5. Do you see those 5 points? Do y'all see what I highlighted? We have to find all of them. A lot of them are easy, okay? A lot of them are easy because you can just look. All right, 0, 0 is 1. How about on the x-axis? Where did that hit? 7, 0, right? That's a 7. Wasn't that the x-intercept? Well, I was moving it because I didn't want my line to go right through my 7. So that's my 7. And then that one up there is also 7, but that's the point, what, 0, 7. This one right here is the intersection of L2 and L3, which we did in the last problem. Right? 3, 6. This one we'd still have to do. Okay? So I'm going to start labeling these. 0, 7, 0, 0, 7, 0. This one, 3, 6. But I should note there from last example, And then our final one here, how are we going to get this final one? It looks like 6-3, doesn't it? But you cannot just do that on a test. You must show the work. So how are you going to do it? You're going to set up a system of equations. What two equations are you going to use? Yeah, what lines do you see intersecting there? The L1 with the L2. So you're going to set up a system of equations with just L1, which is 3x plus y equals 21, and L2, right, which is x plus y equals 9. Does that make sense or not? Yes? Do substitution on that. So I'm going to solve, I'm going to do my steps here. I'm going to solve the second equation for y. So y is negative x plus 9. I'm going to substitute that into the first equation for y. Yes, you could do either one. Either one. So x is 6. I'm trying to squeeze all this onto one page. Do y'all see what I did? I solved equation 2 for y. I took that answer and plugged it in for y into the other equation. I'm solving this now. I get x is 6. I take that answer and I plug it into the first equation. I don't know why I put 4 there. Fourth step is to plug that answer into the first equation. So y equals negative x plus 9. I replace my x with 6. Negative 6 plus 9 is 3. So yes, you are correct. It is 6-3, but you have to show the work. So that last point is 6-3. Questions, comments, concerns? I'm going to give you a problem for you to take home as a homework/quiz problem. All right. I want you to turn it in on Tuesday. And what do we have? We only have 3 more days of class, right, after today. So, if you want, what I'll do is the next class I'll collect this assignment. If you turn it in, it'll be 100 as far as effort, as long as you've done a significant amount of work. But if it's like really good, in other words, if it's aesthetically pleasing to the eye, then like the more effort you put into it, if you use graph paper, if you use color, if you really show me all the work in detail, I'll consider it as bonus up to replacing your lowest quiz with 100. So I basically count it as 100 if you do it, and then replace your lowest quiz with 100 if it's really nice. Pardon me? December 3rd. What? Next class. Yeah, next class. Next week, next Tuesday. What's that? If your quizzes are already at 100, then I'll consider adding something to a test. But it will be only the equivalent of what one quiz is worth in the class. Okay.
So if you good, you'll bring back that grade, the lowest grade you dropped.
No, it's a separate one. I already dropped 2. Yes. So anything else you have that's low, I'll bump it up. What? Oh yeah. Well, hold on. I want to show you something. No. I'm not going to go crazy off some tangent. But look, if I were turning this in for really good credit, then I wouldn't turn in all that junk I just had. I mean, that would be included in my work. But my final page, my final presentation to whoever it is that's reading this, would be a very accurate graph that would show my points wherever they were, right? I don't even remember where they were. What were they? Hold on. That's not that bad. Okay, and then it would draw. I would draw that region. Nice, shaded in, everything labeled, all that other extraneous stuff gone, right? All those other lines and arrows and everything else gone. Just the region with the points labeled, nice, like marked out 7 units, everything real pretty. That's your feasible region. Your final answer. I don't think about this. I don't like business math. All right, well, here's your problem. Let me verify that it is what I want it to be. Okay, yep, this is going to work. All right, solve. Two x plus y less than or equal to 10. X plus y less than or equal to 7. X plus 2y less than or equal to 12. X greater than or equal to 0. Y greater than or equal to 0. What? Why? Which ones? That's the same thing we had last time. X greater than 0 means to the right. Y greater than 0 means up. I would be interested in knowing this. Like when you turn in your thing on Tuesday, you put your name on there. I'd be interested in knowing in the top right-hand corner how much time this takes you. Well, I mean, don't sit there and be like, Deek. But I mean, because you may stop and come back to it, but just give me a roundabout idea of how long it took. Because I want to put one of these on the final, but I want a realistic idea of how long this takes. Now, of course, if you're going to put a lot of effort into it, it's going to take longer, but I mean, if you want. I mean, whatever. It's not required, but if you would keep track of it, that'd be great. Okay, I think that's it for today. You too. Y'all take it easy.